Okay, here's the review. So, really not going to do anything from chapter 1. We're going to move on to chapter 2, which was set theory. So there are a couple things about set theory. There was just the notation that we had. Actually, there was one thing that we did in chapter 1, and it was on the first test. Method of successive differences. So go ahead and review that. Most of you got that, did fairly well on it. So I'm not going to work through one. Go back to the first review. Basically have a list of numbers, and then you take the difference between each adjacent number, and then you create this upside down triangle basically until you get the same number at each on a row all the way across, and you work your way back up. So you can go ahead and look at that. Okay, so chapter number 2, there were different ways of representing information about sets. And sets are just a list of numbers, or really a list of any elements or members. And we used the notation. We could represent a set, and we would say a set is equal to, and we'd use these brackets. And let's just say it's the set of even numbers. So sets can be finite if they have a fixed number of elements in it, like this. So that's a finite length. There are 5 elements. The order is not important. So this set A would be the same as set A if I switched the position of some elements. It doesn't have to be ordered, they just have to be inside this set using these brackets. There's also examples of infinite sets where you sometimes establish a pattern of some sort. So for example, if I did 1, 3, 5, and you usually need at least 3 or 4, and then once I've established a pattern here, which looks like the odd numbers, then I would put 3 dots and then the right-hand bracket. So that's an infinite step that starts at 1 and goes all the way to infinity. You can go from the other direction as well. So if you start from the negative side, you go dot, 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 and you might have -7, -4, -1, and what you can see is I've set up this pattern that there's -3 between consecutive elements in the set, so this would go to -10, -13, but we don't have to list them all. Now on the test, there was this case of list, and it says using the listing method. So the problem said use the listing method to list the set of all integers. Let's do even integers between let's say 20 and 60. So when you're using the listing method, you're doing something like this. You either list them all or you use some abbreviated version of it. Well, I don't really want to list 15 elements, so what I would do is I would write, I'd say set X is equal to, and what we do is we start at the first one that applies on the lower side. Now this is between, so that's where you guys got confused last time. With between means that it doesn't include the endpoints. So if we wanted to list this, we go to the next even integer, which would be 22, and then we would establish a pattern. And once we have established a pattern, then we would go dot, dot, dot to show the pattern repeats itself. And then we could either do, 54, 56, 58, but since we've already established the pattern, really all we have to do is put 58 in there. We don't need to show the pattern on the other side if we don't want to. So if that was between 20 and 60, if I did, how would I write it if I wanted to include, I could say greater than or equal to 20 and less than or equal to 60. If that was the set, then the notation would be, again, the brackets. You'd go 20, 22, 24. I've established my pattern, ... 60. So make sure you carefully read what they're asking for. Now I might do something in this other notation which says, so this is a listing method, this is a word description. And then you have this formalized set builder notation which says looks like this, and then it has a straight line. X is the negative integers. So what this reads as is C is a set of all x such x is a negative integer. I guess I could just say that. It's a negative. X is a negative integer. So if I said to do it in the listing method, this is a set builder notation. The listing method again is this. I'd say C is equal to, and then I put the bracket. And because I'm dealing with negatives, it's better to have negatives go from right to left. So negative integers would be -1, -2, -3. So I'll put them in the exact opposite order here. -1, -2, -3. So I'm having it go that direction, and this shows that it goes on forever. So this is a infinite set in using the listing method. This is a finite set using the listing method. Okay, so that's then there were operations, set operations. So we had, let me just use some examples here. So that would be, that's intersection. And then you have, let's say, B, this U-looking thing, D. So that is a union. And then you have the complement. So those are the set operations. And so if you remember in the previous test, we did, I gave you the elements in the set. I'm not going to write it all out. You can go back and look at the second test, but using letters to represent different sets like this. Okay, we'll do one example just so you know what I'm talking about. You can go back and look at this. So let's say D is B is B, C, F, G. So if I want to perform an operation between these two sets, I could do A intersect B. Now the intersection is the set, so the result is always a set, and it's a set of elements who are in both set A and set B. So these two elements, B and C, are in both sets. So that would be the intersection. Notice it's a set. It's the common terms between the two. When you do a union, say A union B, you list all the elements that are in both sets. So you can basically list out what is in A, and then you go to B, and you say, well, I've already got B and C, so I don't need to do it again. And have that. Now, to do the complement, you have to know what the universal set is. So this is it's not the same as this. This is a union sign. This is just U for universal set. So the complement of a set is equal to the elements in the universal set minus the elements in the set. So basically the complement is everything that's not in D but in the universal set. And then we had the problem like this. Again, you can go back and look at the test. And you can look at the review from this test. Remember, you can quickly page through those, or go through those reviews quickly and look for the elements that I'm talking about here, so I don't have to redo everything. So there's a problem like this where there are three sets, A, B, and C. And then I give you things like n sub A is some number, 35. So that's the number of elements in set A. That's really it's called the cardinality, but that's the number of elements in set A. So that would be what's in this total set. And then I might give you some information about A intersect B. A intersect B is this overlap between set A and set B. And I will give you some number there. And so there's a list of these things, and usually what you do is you start at the center, which is the intersection of all three sets, and then you go to these football-shaped things, because we already know what this side is, and then if we know the total, then we can take the total and subtract this to get that. So if you messed it up on the test, you need to look at it, because you're going to get it wrong again if you don't learn from your mistakes. So what you'll do is you'll basically fill numbers in here, and they're the number of elements that are in each little sliver of this thing. Now I'm not going to give you one that involves words like the last problem on the second test, just because that takes a long time. So look at that on the previous tests. So I think that's it from set theory. Yep, that looks like about it. Okay, so then we went to logic. And I'm going to give you a logic. We did this both in, I'm going to give you a logic problem where you're going to have to fill out a table. So we had 3 or 4 of them. We had 3 on the second test and more on the third test. And so what I will do is I'll give you some kind of logic expression involving letters. And it will have 3 elements, 3 statements that have P, Q, and R. So make sure you know how to do 3 element ones. See what you got to do, and again, you can go back and look at the previous reviews. So there's nothing really new. I'm just giving you an idea of the kind of problem that's involved. So you're going to have 3 columns that involve just the true and false values, that all the possible true and false values. Anyway, review that. Again, that's in both tests 2 and test 3, and there's going to be and, or, and, negation, and, if, then. So you need to know the truth values for these 3, 4 things. And, that's an and, that's an or, that's an if, then, that's a negation. Okay, so that's that. Then we went on to geometry. So there's a couple of geometry things. One thing is we talked about, here I'm going to give you an example that we did in class. And then you have to just kind of think about that. We did a few examples in class. We didn't actually have this on the test. This is part of section 9.3. But if you remember, there was a question about what is the value of this area here if this has a radius of r. And the way we worked that was we used subtraction. So if the distance from here to here is r, then the side of each side of the square is going to be 2r. Because this is r, and then this is r, and you add it together to get 2r. So the area, you have the area of the square, and that's equal to the length of each side squared. So that's the area of the square. And then you have the area of the circle, which is going to be equal to pi r squared. So that's this area. And that area of the square is going to be bigger than the area of the circle because we got these extra little bits here. So the area of the rest, the total rest, meaning these four corners, is equal to the area of the square minus the area of the circle. So that gives us 1, 2, 3, 4 areas. To find the shaded area, you have to take the rest of the area that's left over and you divide by 4 because these are all the same size and shape, they're just oriented differently. So if you plug all that stuff in, you'll get the answer. So you plug that into what you've already done that here. So all you really have to do is the final answer, the shaded area, is equal to 4r squared minus pi r squared divided by 4. What I did is I squared this. 2 squared is 4, r squared is r squared, minus pi r squared. I think the answer was, what they did is they factored out an r squared. So you get r squared times 4 minus pi over 4. So that's your area, shaded area. So that's kind of, it's definitely not going to be that problem, but it's going to involve something like that, simple shapes. So you'll need to know what the area of a triangle is. And that's equal to 1/2 the base times the height. You need the area of a rectangle. That's equal to just the base times the height. You need the area of a circle, which is pi r squared. And what else you might need? Square. Just use that. That's just equal to s squared. S is the size length. So I use this one here. I use that one there. So it might be advantageous to make sure you understand those because I could use those in the problem. So. And then there was the case, there's a couple of cases. Again, you can look back on the last, on test number 3, I guess it was. I think it was 3, maybe 2. No, it was 3. You know, we had these geometric situations. So, you know, knowing the relationship between these angle values, that's, you know, these angles here, the big angles are going to have the same value. And then the small angles are going to have the same value. So these are 2 parallel lines of transversal. I'm not going to put on one of those more complicated angle things, but I may ask you a specific question. So the other 3 cases are the interior angles of a triangle. So let's call this, let's say this is 40 degrees, this is 60 degrees, this one has to be 80. Okay, because the sum of the angles, internal angles of a triangle equal 180, no matter what triangle it is. And then you have the case of the external angle of a triangle. So here's another triangle. And there are more than, let's call this angle 1, let's call this angle 2, we'll call this angle 3, we'll call this angle 4. So what we see here is we see a straight line with a ray going off of it. We know those are supplementary, so angle 4 plus angle 5. The measure, I guess, really the measured values of those equals 180 degrees. We also know that angle 4 is equal to angle 1 plus angle 2. Not equal to 180, but they're equal to the sum of these two angles, which are the opposite interior angles. So again, in the tests, we might have given you, give you some values. This is x, and this is x minus 4, and this is 2x minus 1. And in this case, you use the fact that the sum of the interior angles add up to 180 degrees. So there's two choices. They either add up to 180 degrees or they're equal to each other. I guess we could have complementary angles, but so those add up to 180. So if we do that, we'll get 4x minus 5 is equal to 180. 4x is equal to 185. So x is equal to 185 over 4. Since I just thought those up, that's why I got an answer that's not a nice integer, but just look at those problems that involved x values. Also, another one a problem that you might want to revisit and understand is this one in the third test. I'm pretty sure it's the third test. A lot of people got this wrong. And what you have is, because these two triangles are nestled within each other, they're similar triangles. So this angle here is the same as that angle there. These are both 90 degrees, and then this angle's the same because they're on top of each other. So what we saw there was, let's say I give you this. Let's pick another one. Let's say this is y. This length along here is y. And this whole distance here is 120 centimeters. And let's say this one is 60 centimeters. So the question, and this one is, let's say, 105 centimeters. So how do you figure out what this unknown length side is? Well, you've got two similar triangles. You get this triangle, and you got this big triangle. And these two sides correspond to each other. This hypotenuse, long hypotenuse, is, what was the word I was forgetting, corresponds to this shorter one, and then these two sides correspond. So what we have is you have the distance 105 centimeters. This side length, that side length is equal to, that's from big triangle. This is the big triangle. So you get 120 here, and y is the smaller side. And so you can cross multiply and solve for y. Now that one's actually easier than the one on the test, because if you remember the one on the test, this is the unknown. And I think I gave you something like these two separately. So let's say this one is 80, and this distance is 70. So you do the same thing. In this case, the longer length. So what we're trying to do, let's call that x, since I called it 1y. So the second kind of problem would be you take this length to x, which is this side of the big triangle, to this side of the small triangle. These are corresponding sides. You take the total length, not just 70, but the whole length, 150, divided by this length, 80. So it's this whole side of the big triangle and the whole side of the small triangle. And then you can solve for x. So think about that. Greatest common factor, using two methods that we did in the last test. If you didn't remember what the two methods are, actually there were three methods, but we're not going to do Euler's method, so it's the prime factors method, in the dividing by prime factors method. You can look those up to see which one's which. And there's corresponding procedures to find the lowest common multiple, least common multiple. Then there's the prime factors method, there's the dividing prime factors method. Factoring, problem number 1, since some of you guys got it wrong, when you list the factors of a number, say of 72, you're not doing prime factorization. Prime factorization is when it says prime factorization. What factoring is listing all the numbers that are divisible, 72 is divisible by. So the way you do that is you write 1 and 72, which some people forgot to do that. They started at 2 instead. And then you go up larger numbers and you ask the question, can I divide this by these numbers? And I know this one does it, so I wrote it down ahead. So then you can just take this number, divide by that number, and match them up. So with the one on the test, 72 divided by 2 is 36, 72 divided by 3 is 24, 72 divided by 4 is 18, 72 divided by 6 is 12, and 72 divided by 8 is 9. And so that's factorization. Prime factorization, if I said do prime factorization, which you also need to know how to do, because you actually need it in both of these methods anyway. So whether I was directly asking it or not, when it says prime factorization, that's when you break it up into a product of just prime numbers. So the way I do it here for this number is I keep dividing by 2 until I get an odd number. Then I ask, can I divide that by the next prime number, which is 3? The answer is yes. And so the prime factorization, and you want to write this out in this form, exponential form, is that. So that's what prime factorization is. This is factoring. And then you can use this prime factorization in the prime factors method. You can review the last video if you didn't know what you were doing. Okay, we're almost done. Okay, let me just, and again, I'm just going to mention what some of these things we've already done before. Simplifying fractions. Actually, simplify rational numbers. So if you have 30 over 72, that's not in its simplest form. So you write these out until you run out of common terms that you can cancel out. Now let's just finish it and then I'll explain. So you can see it simplifies down to 5/12 because 30 divided by 2 is 15, 72 divided by 2 is 36. These are not both even, so then you go to the next number, which is 3. You can divide both of them by 3. So this is the final answer. If you were to go from here directly to here, I need to know what you divided by, which would be 6. So you need to show what if you're going to skip the intermediate steps, tell me what you divided by. Because otherwise, you could enter this into your calculator, you get a decimal number, and then you could back it out using the fraction thing, and you get the answer without really knowing what's involved. Adding and subtracting fractions. We did that. That was the last couple of problems on the last test. And there is one of those more complicated ones that we had, like the last problem on the last test. Like 7/8 minus 1/3 divided by 1/4 plus 2/3 or something like that. So make sure you know what you do is you have to do you do the subtraction of the fractions, come with the combined fraction, add the fractions, come with the combined fraction. Once you've completed all of this, then you take the reciprocal of the denominator, multiply it by the numerator, multiply it out, and then simplify it. Okay, what else we got here? convert, we did this on the last test, convert decimals, this is the next to last problem, to fractions. So, what we do is we take our decimal, we make that into a fraction, you multiply this by whatever number of digits. Okay, so this 30.35 becomes 35. And you can always plug this into your calculator and see if you get that back if you forget. So it's to make it something over 10, something over 100, something over 1,000, depending upon how many digits you got in your original number. And then you simplify it by finding a common factor, in this case 5, so you get 70 over 20. So make sure you show the steps in between. Radicals. So this is the square root of something. So if I had the square root of 240, I want you to put it in the simplest forms. Now if you can know what the perfect square factor of this is, then just use it. But if you don't, remember what we did is we did the prime factorization of 240. So that's what you get. So we write that out, 2 to the 4th times 3 times 5. And then we look for prime factors that are raised to an even power. So we have that. That's the one. These are all just to the first power. So we can make it square root of 2 to the 4th times the square root of 3 times 5. So all I've done is I've broken 240 up into these terms. These are the ones that are not raised to an even power. These are raised to an even power. And then all I have to do is take the square root of that. Well, 2 to the 4th power is 16. 2 times 2 is 4 times 2 is 8 times 8 is 16. So it's really the square root of 16 times 15. And then the square root of 16 is 4. So that's how you do that. Also, we looked at if you have a square root like this, we did that in class, you can go back and look at that, or if you have something where, say you have that, okay. In this case, you break it up into 2 radicals, then you multiply by the square root, the denominator, which is the square root. When you multiply these two together, you're multiplying fractions together. Square root of 3 times the square root of 3 is 3, and then you can multiply these two together. Well, 7 times 3 is 21, so it's the square root of 21. And then you'd look to see if you can simplify this by having any perfect squares that are factors of this, which in this case is not. You have 7 and 3, which neither of those are perfect squares. And in this case, you're really starting almost right here. All you have to do is just multiply the numerator and the denominator by the square root of 5. So you get 2 square root of 5 over 5. And those are the final ways to simplify radicals. We talked about this today, rounding. So make sure you can round to a certain number of tenths, thousands, hundreds. Convert decimals to percent. Everybody should get this. So remember, if you have a decimal, there's 2 ways of thinking about it. Is you can take this number, multiply by 100, and then put the percent sign. Or you can take that number and move the decimal point 2 places. So you'd have 0.350 point. So I moved it 1, 2. Of course, the 0 in front is superfluous, so I just put 35%. Okay, so that's converting decimals to percent. Then we have fractions to percent. So you just have one extra step. You have to convert a fraction to a decimal. So you'll use your calculator for that. So here's a fraction. plug it in your calculator. Don't do all the digits. Maybe do 2 or 3, 3 maybe. So you do 2 divided by 7, and if you round off correctly, you get 0.286. Okay. And actually, I'm going to ask you to do that. So we're going to do 3 digits round to correct. That'll give you a practice for rounding. Okay, so that's the decimal equivalent. So again, you can multiply by 100 and add the percent sign, or you can move the decimal point 2 places to there. And somehow I got rid of, oh, it's down here. Okay, where am I? I don't know actually how I did that. I think you just drag it. My menu here. Does that work? No. Anyway, I'll figure out that later. Something we actually didn't cover today, but I put on the final, is you get a question, what is some percent of 133? Question mark. That's not the exact problem, but calculating percent of something is basically the first step is convert percent to decimal. So what we do is we say 25% is the same as 0.25, the decimal 0.25. All I'm doing is moving the decimal 2 units to the left, or dividing by 100. I've taken the one that said divide by 100, take the percent sign off. So that's my decimal equivalent. And so to find 25% of 133, just multiply the decimal equivalent of the percent times the number that you're starting with, which is, it's going to give you 33.3, not percent, but just 33.3. That's a number. This is a number. So we never do any, we would not do, this is not right. If you did that, you might say, well, I convert that in my head, but no, don't do that. Convert percent to decimal, do the math. Okay, now another question I'm going to ask you. What is, what exactly, how does I word this thing? Oh, no, not that way. That's why it didn't sound right. Say 32 is what percent of, oh no, that's another question. Well, actually we can do that. 32 is what percent of 70, question mark. Well, here we are looking at a ratio, 32 compared to 70. So what we do is we take our fraction, which is the percent of is always the denominator, the thing we're taking the percent of. So you take 32 divided by 70, you get the decimal equivalent of that fraction. And then you convert it to percent by multiplying by 100 and putting the percent sign, or moving the decimal point 2 places. Okay, so that's 32 is what percent of 70. Now one more question is, 10 is 30% of what number? So it's kind of a question here. If I said 32 is 42% of what number, the answer would be 70. So it's used as the same ratio, but it's in a slightly different form. So the way you do that is you take the number and you divide by the decimal equivalent of the percent that they're talking about. So if you do that, you'll get 10 divided by the decimal equivalent of 30% and 33.33. So that 10 is 30% of 33. If you go the other direction, so if we said 10 is what percent of 33.3 question mark, then we would take 10 divided by 33.3, 10 divided by 33.3, oops, just a decimal point there, 0.3, don't run that. Then I push enter and I get 0.3. Okay, so it's just kind of going backwards. And that's the decimal equivalent, which is the same as 30%. So those are the kind of tricky parts. And then finally, and I'll just let you look at your homework for this, there'll be a word problem, 2 word problems, talking about percent increase and percent decrease. So if something increases, calculate percent increase. And I should say decrease, because I just said increase. So you get percent decrease. So look those up in the book. The key thing is that these are always positive numbers. So percent increase is the new value minus the old value divided by the old value. That'll give you a decimal, and then you convert that to percent. Percent decrease, you take the old value and you subtract the new value, because the new value is smaller than the old value, but you divide by the old value. So it's not, you always use the old value, the previous value, in the denominator. And you do that, so this subtraction is always positive. And you get the decimal number, and then you convert it to percent by multiplying this number by 100 and putting a percent sign on there. But the key thing is you want to say 10% increase. You want to make sure that you put the word increase or decrease afterwards. Otherwise, we don't know without looking at the calculations. So that's not very useful. Okay, so I'm going to take one last look here and see if there's anything that I forgot to tell you to do. Okay, I don't think so. Okay, so that's it. So, you don't watch this. If you have a good A, then you probably don't need to do anything else. But if you're right in the borderline, you probably want to go back and look at homework. You want to go back and look at the other reviews that I had posted. Again, you don't have to watch the whole review. You can just kind of go through there quickly and find the topic that I mentioned in here, and then look at it. Look at your tests to see where you went wrong. Those kinds of strategies.